test, and it wants us to write the coordinates of the point B. So we go along the x-axis first and then up the y-axis second to get the coordinates. So our coordinates will be 4 along the x and 5 along the y, so that gives us the point 4, 5. We want to find the coordinates of the midpoint of AB. Well, if we count along from A and up to B, we can see it's 1, 2, 3, 4, 5, 6 along and 2 up. So the midpoint will be 3 along and 1 up, so just here. So that would give us the coordinates 1, 4. If you haven't got the diagram and you just want to do it using the numbers, well, we know that A is at the point -2, 3, and B is at the point 4, 5. And if we just take the average of the x coordinates and the y coordinates, we can then find out where it is. So the midpoint, we're going to -2 plus 4 divided by 2, and 3 plus 5 divided by 2, and that also gives us the point 1, 4. And the last part of the question, it wants us to, on the grid, draw the line y equals -3. Well, we can see the y value is -3, so therefore, it will be everywhere. So it will be everywhere along this line where y equals -3. On question 2 in our test, we've got L is drawn on the grid below. We want to find the equation for the straight line L and give our answer in the form y equals mx plus c. So y equals mx plus c. Well, we know that m is the gradient and c is where it crosses the y-axis, or known as the y-intercept. So we've got m because it's our gradient, and we've got c is where it crosses the y-axis. So we can see c straight away is easy to find. That's just going to be 1. So we know that's going to be 1. Now we want to find the gradient. So the gradient is equal to our change in y over change of x between 2 points. Just pick 2 points. So we've got that point, 0 to 1, and then we've got another point that goes through here. Okay, and we go along 2, and we're going up 1, 2, 3, 4. Just check the scale, that is 4. So the gradient is the change in y over the change in x. So it equals 4 over 2, which equals 2. So therefore our gradient is going to be 2, and m is going to be 2. So therefore y will equal 2x plus 1 for our final answer. Right, in question 3, the graph shows the depth d in centimetres of water in a tank after t seconds. We want to find the gradient of this graph and explain what this gradient represents. So let's just zoom in on the graph to make it easier to find the gradient of this graph. So we can see that it goes through the point exactly halfway between 180 and 240, so that's 210, and it goes all the way down to 0. So if we go from this point here to this point here, so if we go from A to B, we can see our change in y is going to be minus 210, and we can see our change in x is going to be 140. So our gradient, remember, is equal to our change in the y value over the change in the x value. So we've got minus 210 over 140, and that just equals minus 1.5, or if you like minus 3 over 2 if you want to leave it as a fraction. So we found the gradient of the graph. Now, what does this gradient represent? Well, if we look, it says this is the depth and this is the time. So this is how much the depth is going down for each second of time. So it's our rate of change in depth. Okay, it's our rate of change in depth per second. Change of depth, and the depth is in centimeters per second. So that's how much it falls for every second. Okay, so the depth gets minus 3 of 1.5 lower, this gets 1.5 lower, minus gives us the lower, for every second that time passes by. Right, in question 4 we have the equations of 4 straight lines here, and 2 of these lines are parallel. Write down the 2 parallel lines. Now, how do we find out if things are parallel? If we remember, the equation of a line has the form y equals mx plus c, and this here gives us our gradient. Now we know that if the gradients are equal, then the lines must be equal. If you think about it, if the amount is going up for every unit it goes along, if that's the same rate of increase, then the lines must be parallel. Okay, so if the gradients are the same, the lines must be parallel. So what we need to do is get these all in the same format. So it's y equals mx plus c. So the first one needs no change. It's y equals 2x plus 4. Now the second one, we need to divide by 2 to get the y on its own. So we get y equals x divided by 2 is a half x. 4 divided by 2 is plus 2. Now on this one we're going to take away the x first, so we'll do a bit of intermediate working up here. 2y equals minus 2x plus 4, then divide by 2, so y will equal minus 2 divided by 2 is minus 1x, plus 4 divided by 2 is just 2. We don't probably need the minus 1. We know if we've got minus x, that's minus 1 lot of x. Now on this one, the way I'd do this, I'd add y to the other side, so I get 2x equals 4 plus y, and then subtract the 4 to get the y on its own. So y will equal 2x minus 4. And which of these have the same value for m? So look through all the values of m, so that's effectively minus 1. And there's 2 of them. Sorry, use a different colour here. And there's 2 of them which have the same value. So those are our lines, and that was line A and D. The first and the last line have exactly the same gradient and are therefore parallel. Right, question 5 comes in 2 parts. The first one is to calculate the length of A and B here. And we're to give our answer to a correct 1 decimal place. So we have AC and we have BC. So therefore we know we can use Pythagoras' theorem. We should know that AB squared will equal AC squared plus BC all squared. So this side squared here plus this side squared here equals that side squared. So AB all squared will equal 12.7 squared plus 8.3 squared. Now if you don't use the Desmos scientific calculator, which you can get at desmos.com, I would highly recommend you using this. So I'm going to, because you can see all your working and you can go back and check it. So you've got 12.7 squared plus 8.3 squared, and we've got our answer is 230. But we don't want that, we want AB. So we need to square root our answer. So square root, press equals, and then we can use our answer, square root of answer, and we get the answer as 15.1716 and so on. We don't need any more places because our answer, we just need to get to 1 decimal place. So let's do that. The first decimal place is 1, second is 7, so we're going to end up rounding up because 7 is bigger than or equal to 5. So we get 15.2 centimetres. Now in the second part of our question we've got another triangle DEF, and we have been asked to find the length of DE. So let's label up our triangle first. So we've got an angle here, so this side will be our opposite side, and this will be our hypotenuse, and this will be our adjacent side. So we want to know what the opposite side is. We've got the hypotenuse and we've got the angle at 40 degrees. So the formula that connects the opposite and the hypotenuse is sine theta equals O over H. So we do sine of 40 equals O over 25. Using our algebra, we times by 25 to get the O on its own. And then we can just put that into our calculator. So we do 25, new line, 25 times sine of 40, enter, and we get 16. So we get O will equal 16.069, so on. So three significant figures. There's the fourth. It's more than 5. We're going to round up to 16.1 meters. In question 6, we've got a units question, and it's a volumes units question. We want to convert 2 meters cubed into centimeters cubed. Well, we know that 1 meter is equivalent to 100 centimeters. So therefore 1 meter cubed will be equivalent to 100 times 100 times 100 centimeters cubed, because you think about it, if each of these edges is 1 meter, then each of them is equal to 100 centimeters, and that will equal 100 centimeters, and that will equal 100 centimeters. And we can see a 1 meter cube will equal 100 times 100 times 100 centimeters cubed. So therefore 2 meters cubed will equal 2 times 1 meter cubed, which is times 100 times 100 times 100 centimeters cubed, which gives us 2 million centimeters cubed. Right, in this question, the diagram shows a cuboid, A, B, C, D, E, F, G, H, and we're told the length of AB, so AB is 7, and we're told AF is 5, and we're told FC, this diagonal here, is 15. And we want to calculate the volume of the cuboid. So we've got the 5 and the 7. We need this BC. But before we can find that, we need to find out what AC is. So we're going to use this triangle FAC to try and do that. So here we go. We're going to use ACF. We know that AF is 5 and we know that FC is 15. So therefore AC squared will equal 15 squared minus 5 squared, which equals 200. Now I'm not going to bother square rooting that, because I know this is equal to the square root of 200, but I'm going to have to square it again when I try and work out BC, because I now need to look at this triangle ACB, okay, to see that. So let's just draw that triangle in there. So there's ABC. I know that this side is square root of 200, and I know that this side is 7. So therefore BC squared will equal the square root of 200 all squared plus 7 squared. Well, that is just going to be, not plus 7 squared, sorry. I'm going to take away this 7. So here we go. So we're going to get 200 minus 49, which equals 151. So BC will equal the square root of 151. So the volume of our cuboid, let's just get that all on one screen. So our volume of the cuboid is 5 times 7 times that. So the volume will equal 5 times 7 times square root of 151, and we wanted the 3 significant figures. So we're going to our Desmos. So we do 5 times 7 times square root of 151, and that equals 430.087, and so on. And we are asked to give that to 3 significant figures, so that is just 430 to 3 significant figures centimetres cubed.